Well, we're back. This time we're going to take a look at what do we do now that we've got this sequence of x's and y's, that is literally points that are on the curve that is the top half of the circle. So what we'd like to do is connect each one of these and find a way to make a distance between them and calculate a distance between them so that we could add it up and approximate the distance around the circle. Now, as you can see, there aren't a whole lot of points here, so this is not going to be a very good approximation. It's going to be pretty rough as the approximation for half the circumference, but we got to start somewhere. So what we're going to do is back out of our list. So go quit out, and then I like to just clear the screen. That way I don't have any clutter here. And I'm going to clear these key presses in case you want to watch. So what we're going to do is use the distance formula. This is the standard distance between 2 points, x1, y1, and x2, y2. And so by finding the distance between these 2 points, we can generate the length of a particular segment along the curve. So what we need to do is find the difference between, so x2 minus x1. So we're going to find the difference between subsequent sort of looking for subsequent x values and y values. So we're going to find this x2 minus x1 and y2 minus x1 for each pair of values in our table. So for this to this, and then the corresponding y value. So in order to do that, we need to use a difference operator. So on the home screen, we're going to go back to that list menu, the second stat, and we're going to go over to ops, and you'll see if you, excuse me, if you walk down the cursor, you'll see at number 7, delta list. Delta in mathematics, that Greek symbol looks like a triangle, just means change. And so it means change in the list. So we're going to select that. And now it needs to know which list we want to pay attention to. So what we're going to do is we're going to find the delta list for list 1. And I'm going to close out the parentheses. And I'm going to tell it to store this information. It's going to store basically x2 minus x1 for each subsequent pair. And I want to store it in L3. So far we've used L1 is the x values, L2 is the y values, and L3 represents the delta list. That is the x2 minus x1. And so when I hit enter, it goes badunk, and it saves all that in L3. And you'll notice the difference in each one of the x coordinates is just 0.2 each time, which is kind of the way we wanted it. Now we're going to do the exact same thing. This time we're going to do it for our y values. And the y values are not nearly as consistent, and you'll see why here in a second. So we're going to do delta list, this time not for L1, but for L2. Those are our y values. And I'm going to store that information in L4. Now it's important that you don't store over the top of things. So at this point, it's a good idea when I hit enter, it's a good idea to check and see what I've got so far. So I'm going to go into stat, enter, and you can see L1, these are my x values. L2, these are my y values. Notice that L3 and L4 are a little bit shorter lists. That's because L3 is saying what's the distance between, for L1, what's the distance between, let me walk it over here and here. That'll be the first value in L3. And then from here to here, that'll be the second value. And then from here to here, all the way down. So there'll be one less or one fewer value in L3 than in L1. And same thing for L4. So you'll see this is the change in x, this is the change in y. Change in x, change in y, change in x, change in y, all the way down the list. Now, I don't want to tell tales out of school, but every single one of your L3s for every single trial run that you do is going to be the same number all the way down, because delta x is always the same. It's always that change in x that you're using. So now that we have that, we're going to go back to the home screen. I'm going to clear out my list here. And what I really want to do is compute the difference formula, excuse me, the distance formula. I want to compute this thing, the square root of that squared plus that squared. Now, this thing right here is just L1. 1. That's what we call, or excuse me, L3. Getting ahead of myself here. Delete. That thing right there is just L3. And this thing right here inside the parentheses is L4. So what I'm going to do is program the calculator to take the square root of L3 squared plus L4 squared, and I'm going to store it, and I'm going to store it someplace where I'll be able to find it later. I'm going to store it in L5, okay? And that's this step right here. So back to the calculator, let's do this, and then we'll take a break. So back into my list menu, over to ops. Oh, no, I don't need to do this right now. Sorry. I'm going to take the square root of list 3 squared plus list 4 squared. And so when I do that, this is the distance formula. That's the exact same thing as what's written right here, right? By virtue of the fact that we took this. So basically we're doing a little bit of basic computer programming. And so we're telling it to take this list and square it, the items in this list and square it, and add it to the items in this list squared, and then take the square root of the whole thing. But now we have to tell it, I'm going to use the cursor over key to get outside of the square root. And now I'm going to tell it to take that whole thing and store it in L5, like that. So this is telling it what to do. Once I hit enter, boom, it produces a whole bunch of numbers that get stored, just for verification's sake, in L5. So you can see them right here. These are the distances, literally the distance between the first 2 points, the second 2 points, the next 2 points, the next 2 points, and the next 2 points. So what we have now is all the distances all the way around that little half circle. And you'll notice all the distances are positive because they're all just distances. It's how far is it from here to here. So what we can do now is add up all of these distances. And once we add up all the distances in L5, that's going to give us our best guess for half the circumference, the distance around half of a circle. So the very last thing that we need to do in order to calculate our best guess, our approximation, is to sum the entire list 5. In this case, it's only a couple of numbers. It's not a big deal. But later on, it's going to be a lot more numbers. The smaller the delta x, the more numbers that you have to add. So first of all, go back out to the home screen. You can leave it up if you want. I'm going to clear this out. And now all I'm going to do is go into my list menu again, second stat, walk it over to operations, and I'm going to go all the way down to sum. And it's a little ways down here. It's not cumulative sum. Oh, whoops. I'm in the wrong menu. That's why. It's in math. There we go. Sorry. I'm going to walk it down. Now that I'm in math, I'm going to walk it down to number 5. And I'm going to hit sum. And it's going to say, okay, what do you want me to add? Now I could type in numbers if I want, but what I really want it to do is add all the things that are in list 5. And you can close the parenthesis if you want, but you don't have to. Now, once I do that, it's going to give me a number, a single number, 1.532977718. That is the number. That right there is the number that you would have to type in, or write in, I suppose, at the very end in your results page. That's what you write right here. That's our best guess for half the circumference of the circle. So 1 point, blah, 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 all that stuff. And then the next step is to take that number, this guy right here, and divide it by the radius, right? C/2 divided by the radius. So what we need to do is figure out our radius was 1/2. So we're going to divide that by 0.5, and it spits out this. That number right there. That's our best guess for what pi is based on what we're seeing, based on this circle with this radius, using this change in x to find this approximation for pi right here. So after all this, 3.065955436. Now, you know and I know that that's nowhere near pi. But you can figure out what to do from here, because you have a whole bunch more. Each step of the way, the next step, the only thing that's going to change is that delta x, that step size, that change in x. So you're going to run the exact same equation with the exact same radius. You're going to go all the way back to the beginning and run new numbers. But don't forget, and this is important, not only do you want to clear this screen, but you want to clear out all your lists. So each time you're going to want to go up here and say clear, walk it over and hit clear, walk it over and hit clear. There's a faster way to do this as well, but this, at least this way, you're guaranteeing that everything gets deleted, or everything gets, cleared. And so by the time I'm done, I have, whoops, that's not what I meant to do. Yep. By the time I'm all done, I will have cleared all my lists and I'm ready to go. And I can start again. And remember, starting again means I start with this sequence function. I go down here and hit sequence, and I start it all over again following the directions. Okay, I hope that helps, and I hope that gets you started and gets you moving. You've got several examples to do, but once you get the hang of them, it doesn't take very long. The biggest trick is in between each trial, make sure you delete your lists, right? That becomes important. And of course, once you step down here, you have to come up with a new equation, which means we're starting from a new left-hand side and right-hand side, right? So depending on what the value of r is, up here, way up here in the diagram, depending on what the value of r is, it could go further out this way and further out that way, depending on how big r is. So make sure you're deleting, you're clearing out your lists in between each trial, and make sure you know what the domain is for your half circle. Have fun.